Hello and welcome back. We're going to take a look at another example where we have to find the intersection of two lines, and we're expecting to find two skewed lines in here. So we'll see how that reflects when we are solving the problem algebraically. So in this case, we're given the equations of two lines, L1 and L2. They're both in parametric form. So I'm going to rewrite the equations down here. So for L1, we have the equations x equals negative 1 plus s for x. For y, we have 3 plus 4s. And for z, we have 6 plus 5s. For line L2, we have the parametric equations x equals 4 minus t. For y, we have 17 plus 2t. And for z, we have 30 minus 5t. So I just wrote the parametric equations indicated in the problem. So to find the intersection point again means that we need to find the x, y, and z that is the same or satisfies both equations. And for this, we're going to use the fact that the x coordinates have to be the same. So we'll equate negative 1 plus s with 4 minus t. And then we can choose the second set if we wish. Right here, 3 plus 4s equals 17 plus 2t. Let's be consistent with our coloring system. So that would equal 17 plus 2t. And last, we have 6 plus 5x equals 30 minus 5t. So obviously we can use any set of equations because we are solving for only two variables, so we do not need to use all three of them. So, and in this case, I'm going to choose equations with the smaller coefficients. It seems that the first two equations have smaller coefficients, so I'm going to grab these two and solve the system. So as I am rewriting the system, I'm going to also simplify because why not? I'll bring negative t to the other side. That will give s plus t equals 4 plus 1, which is 5. And for second equation, we have 4s minus 2t equals 17 minus 3, which is 14. I will simplify the second equation. So s plus t equals 5. And the second equation can be written as 2s minus 1t equals 7. So simply divide by 2 every term in the equation, both sides. As you can see here, we have t and negative t. So the term t has opposite coefficients. So which means that it will be convenient to solve by using the elimination method. So we can eliminate the variable t by adding both equations. That will give 3s equals 12. And what a convenient equation to solve. So s equals 4. And since s plus t equals 5, the value of t must be 5 minus 4 or 1. So with s value of 5 and t value of 1, we're going to try to solve or find the coordinates from each line. So for line L1, remember that x was negative 1 plus s. So negative 1 plus 5 is 4. The y coordinate is 3 plus 4s, so 4 times 5, which equals 3 plus 20, 23. And the z coordinate is 6 plus 5s, so 5 times 4, which makes it equal to 36. So if there is a common point between two lines, for line L1 has to be 4, 23, and 36. Now let's take a look at line L2. For line L2, we're using the scalar t, which we found out to be 1. So for line L2, we have x equal to 4 minus t. So 4 minus 1, that's 3. For the y coordinate, we have 17 plus 2t, so 17 plus 2 times 1, which equals 19. And for the z coordinate, we'll have 30 minus 5t, so times 1, so that's 25. So in this case, then we'll say that if there is an intersection point for line L2, it has to be at x equals 3, y equals 19, and z equals 25. Now, since these two points have different coordinates, it means that this cannot be an intersection point, which tells us that the two lines do not intersect each other. However, we were able to find the values of s and t. So the fact that we were able to find the values of s and t, but they didn't produce the same point, tells us that the point of intersection would have existed if the lines were not going in two parallel planes. So the lines must have been in two parallel planes, different directions, right? And as you can imagine, then we're going to say these 2 points would have existed if the lines were on the same plane, but it seems that they don't meet each other because they are located in two different planes, which have to be two parallel planes for the lines not to intersect. In other words, we're going to say that these two are skewed lines, okay? So skew lines. And this is what the algebraic solution would look like when you have two skew lines. I hope this made sense, and thank you for watching. Bye for now.